Welcome to a tutorial on simplifying rational polynomial expressions presented by the Regent University Math Tutoring Lab. There are four things we need to think about in order to simplify rational expressions. First, we need to go over some key terms. Second, we need to examine the steps for operating on rational expressions. Third, we will learn the general process for adding and subtracting rational expressions. And finally, we will learn how to multiply and divide rational polynomial expressions. First, we need to understand a couple of key terms before moving forward. A rational polynomial expression has one or more polynomials represented in fraction form. A shared factor is present when more than one polynomial has a common factor, after factoring. These shared factors will make operating on our expressions much easier. Next, we need to memorize the beginning steps for operating on rational expressions. Regardless of what operation we want to use, always start by factoring anything that can be broken down. When factoring, we should be left with irreducible factors when we're done. These factors may be constants, monomials, or linear polynomials. Once we have factored everything as far as possible, cancel any factors common to the numerator and denominator of the same fraction. Now we're ready to operate on our expressions. If we want to add or subtract, we need to find a common denominator for our fractions. Just like with numerical fractions, multiplying and dividing can be completed immediately after simplifying our fractions. The first thing we do in order to add or subtract our fractions is to factor each numerator and denominator until only irreducible factors are left. Then, we cancel shared factors in each fraction. Then we need to find a common denominator from the factors present in each of our denominators. Our common denominator is a combination of all of the unique factors in our denominators, including any that are used more than once in a single fraction. Once we know what our common denominator will be, we need to multiply each fraction's numerator and denominator by the factors its denominator is missing. Once all of our fractions have a common denominator, place all of the numerators over a single denominator and operate using the order of operations. Don't forget to group each numerator with its sign, especially when subtracting. After operating, group and reduce like terms. Finally, check if our answer's numerator and denominator share any factors. Now let's do an example of adding rational expressions of polynomials. We're given x squared plus 2x plus 1 divided by x squared minus 1. This fraction is added to x squared plus x minus 2 divided by negative 2x minus 4. First, we want to factor both numerators and denominators. Our first fraction factors to x plus 1 times x plus 1 divided by x plus 1 times x minus 1. The second fraction factors to x plus 2 times x minus 1 divided by negative 2 times x plus 2. Our next step is to cancel common factors that appear in the numerator and denominator of each fraction. In our first fraction, we can cancel a factor of x plus 1 since it appears in both our numerator and our denominator. In our second fraction, we can cancel the factor of x plus 2 because it is present in the numerator and denominator. Once we finish canceling, we are left with the fraction x plus 1 divided by x minus 1 added to the fraction x minus 1 divided by negative 2. Now we need to find our common denominator. We find this by multiplying each factor present in the denominators of our fractions. For this fraction, our common denominator is negative 2 times x minus 1. This means that we need to multiply our first fraction by negative 2 over negative 2, and our second fraction by x minus 1 over x minus 1, because these were the factors they were missing. This produces the fraction negative 2 times x plus 1 over negative 2 times x minus 1. This is added to the fraction x minus 1 times x minus 1 over negative 2 times x minus 1. Now that both fractions have the same denominator, we can add our numerators together over a single denominator to give us the quantity negative 2 times x plus 1 plus the quantity x minus 1 times x minus 1, all divided by negative 2 times x minus 1. To simplify the numerator, we need to multiply inside our parentheses. This includes foiling our two factors of x minus 1. Multiplying inside our first set of parentheses gives us negative 2x minus negative 2. We add this to the x squared minus 2x plus 1 that we got from foiling inside our second set of parentheses. Now that all of our work inside parentheses is done, we can remove them and order them so that we have x squared minus 2x minus 2x minus 2 plus 1, all divided by negative 2x plus 2, which we get from multiplying the factors in our denominator. By combining like terms, we achieve the fraction x squared minus 4x minus 1 all over negative 2x plus 2. Since our numerator can't be factored any further, we don't have any factors to cancel. Now let's learn how to multiply and divide rational expressions of polynomials. We start by factoring each numerator and denominator. If we are dividing two fractions, we need to find the reciprocal of the bottom or right fraction, depending on how they're displayed, just like we did with numerical fractions. From here, both operations follow the same steps. Next, we want to eliminate any pairs of the same factors that are shared in any of our numerators and any of our denominators. Multiplying and dividing does not require common factors to be part of the same fraction, as long as one factor appears in a numerator and the other factor appears in a denominator. After canceling, multiply the remaining factors in the numerator and denominator as a single numerator and a single denominator. Finally, we multiply out the factors in the numerator and the denominator of our answer and simplify anything that remains. Now let's do an example of multiplying three polynomial fractions. Our first fraction is x squared minus 4 divided by x squared plus 5x plus 4. Our second fraction is 2x squared plus 2x divided by 3x plus 6. And our third fraction is x minus 1 over 6x squared. Now we need to factor everything in each fraction. Our first fraction factors to x plus 2 times x minus 2 divided by x plus 1 times x plus 4. Our second fraction factors to 2x times x plus 1 over 3 times x plus 2. Our third fraction's numerator stays the same, x minus 1, and our denominator factors to 2x times 3x. Now, we can line up factors to cancel. Looking at our fractions, we see we can cancel factors of x plus 2 in our first and second fractions, x plus 1 in our first and second fractions, and 2x from our second and third fraction, because one factor of each of these appears in a numerator and a denominator. Now we're left with the fractions x minus 2 over x plus 4, 1/3, and x minus 1 over 3x all multiplied together. We multiply our numerators together to get x minus 2 times 1 times x minus 1 all over x plus 4 times 3 times 3x. Using the FOIL method on our numerator and multiplying our factors in the denominator gives us an x squared minus 3x plus 2 divided by 9x squared plus 36x. We should not have any common factors in our answer because we canceled them all earlier. Thank you for taking the time to learn more about rational expressions of polynomials and for making the most of your Regent experience.